All right. Well, that was awesome, actually. So just to kick it off, it sounds like what we've got here is an opportunity with SDNs in the carrier network to solve two kind of problems. One is lower the cost per bit or make it cheaper. The other is to offer services. Whoo, hi. So Google, you're doing a lot on the lower cost per bit. You're also talking about adding services, which kind of helps you guys manage your bandwidth. Axel, my question is for you primarily. I know you're going to be put on the spot a lot. I'm going to tell you right now. Will these services be data-based, kind of like what Dave is talking about, offering like the full view of the network up to like application providers? Or are we talking about more services that you guys can deliver quickly, which he also did talk about?
I think it's actually both. So is that big question, is the future of the carrier the dumb pipe? I think it's clearly not. If it would be, at one point, there would be no funding to build the dumb pipe anymore. So I believe in very much what Dave presented, what Michael presented earlier from Juniper as well. It's the same story. The applications will only be able to make efficient use of the network if we have the signaling going on. So I think definitely both will happen.
So when we're talking about over-the-top providers, like if I'm Netflix, and I would love to know the cheapest, easiest way, or the cheapest way for consumers and the best way to deliver them service on your network. Maybe I'm using something like OpenRadio, right? You as a carrier have a slightly different agenda in extracting perhaps the most profitable, or maybe the one that doesn't clog all of your other services. So how do you negotiate having that information with those kind of service providers, and how do you see that kind of playing out?
That's an interesting question, and any prediction remains difficult, especially about the future. So it's something between the Googles and the carriers of this world, which has to be worked out. I think there is an opportunity because, for example, your interest is to bring your content to our users, and our interest is to serve our users in the best possible way. And we both want to make some money out of it, so I think that's a good basis to come to an agreement. But it's not there yet. So we had quite some interesting discussions at the ITF as well. There was a BOF on how the infrastructure and the applications could actually talk to each other, and there's no agreement yet. So I think that's indeed a large space where we can optimize.
And I mean, with the Google, kind of the external-facing stuff, I know you're not there yet, but are these kind of the discussions that y'all are having and thinking about, or are you thinking more on,
The external peering, of course, is a much, much different space. I'll point out that in the Netflix space, Netflix is playing one carrier off another with different content distribution networks, et cetera, and they're doing their own real-time management of bandwidth. So I think that the real-time network weather map and balancing one ISP versus another is a whole other space. Even beyond SDN, an incredibly complex space.
All right. And where does we talked about OpenFlow a little bit, but there was a notable absence as we got kind of further up in talking about things. So if you guys can kind of go down and talk about where OpenFlow fits and kind of where it stops when we're talking about carrier and service provider networks. We'll start with Dave.
The non-carrier. So it's yet to be seen exactly where OpenFlow is going to start and stop, just because the protocol is so new and so young. There's many bits of functionality that we need in protocols, and we can adapt OpenFlow to do this, or we can choose other protocols to do this. So for example, we know we need to be able to programmatically have configuration data models for elements. We know we need to have layer 3 addresses to be able to put into routing tables. We need to be able to have MAC addresses put in. We need to be able to have encapsulations programmed. We need to be able to have QoS programmed. I alluded to with analytics, we want, say, for example, NetFlow or IPFix to be able to be programmed in there. We also want the ability to have X-Connect and the ability to have the Gazintas and the Gazautas be able to connect to each other at the data center WAN gateways and other places. You begin to put this functionality together, and I picked these in particular because, one, most of them are not standardized at any standards body. Two, the only way to put them into a router today or into a switch today is via CLI. Three, we know that if we take these features together or independently, we now have the SDN picture that we're talking about, which is being able to, again, have the output of a classifier, have a particular analytics entry associated with it, or the ability to put layer 3 entries into VPN tables and still distribute those over BGP. So let me dial all the way back to the question you actually asked. The question was, where does OpenFlow start and stop? We don't know yet. We know that where we're trying to figure it out as an industry is, where are we going to go? Where are we going to go with this protocol? Can all of those features be put into the protocol, or are there other protocols that need to go there? Are we going to change the architecture of OpenFlow such that we're going to be able to export or extract or learn a topology of a network, or we're going to use a whole other protocol for that? The boundaries of where OpenFlow starts and stops actually is at those decision points. There's a whole bunch of other features and functionality that need to be built into an SDN-enabled network, and we have to figure out where it goes.
And you would argue that you need other protocols would serve that just as well, and perhaps we don't want to burden OpenFlow with all of.
So I've built and worked on a lot of protocols in my day, and there's quite a few successes and there's quite a few failures. And just speaking quickly about some of these, when I take a look at the other programmatic interfaces that I've worked on, again, whether it's forces or GSMP or SNMP or core IDLs or XML interfaces or whatever the case is, one of the failures that many of those had, COPS and PCMM can go into this as well, is that once we had a TCP connection for a protocol, we took every feature we ever could think of and put it into that one TCP session. We know better than that. We know better that we do need a modular approach to be able to solve this so we don't get bogged down in standards and we can find the right protocol for the right function. So I do believe, without a doubt, developers need a modular workflow approach to be able to accomplish this, which either means a protocol with multiple sessions to be able to do these different functions, or it means a suite of protocols.
Anyone else?
Sure. So the question was, is OpenFlow it, or do we need more, right? So I think one analogy I like that Nick uses often is, one way to think of this is, what is the x86 instruction set that we have to the low-level hardware? And OpenFlow is one attempt at figuring out what that instruction set is. It's not clear, it's broad enough, it's not clear, it's sufficient, but I think the goal is to make it broad enough that you can layer the other abstractions on top of that instruction set, instead of having a large number of different protocols that are operating at the lowest level. So you can keep the data plane simple, define a sufficiently rich instruction set, and then all these things Dave was talking about and Axel was talking about, which are, what's the network configuration, what's the network state, what resource allocation decisions can I make, are things that are layered on top of that simple, relatively easy to implement interface. That's how I would look at that.
Okay. Where is the opportunity for startups here? I know when I talked to Urs, and he was talking about his consumer facing, so the external Google network, he was like, we don't want to build it, we've got to have other things to make it a little bit broader, because you're right, it's complicated, it's different. Telco, I mean, I lived through the telcos gear startup mania where people were building gateways and all sorts of fun things. So what do you see as an opportunity for a company that isn't a Cisco or a Juniper in this kind of space, selling to carriers or data center?
Well, still, it's quite an engineering effort to build a proper scalable core router for a carrier. And it's not as simple, just put OpenFlow on top and you're done. So I don't believe we're going to see a massive amount of successful startups who are going to sell new core routers to service providers. We were in that phase during the bubble burst times, and all those vendors have disappeared. And so I would be very realistic. But we see, and I still believe, it's the beginning of a revolution, and it's the first big change. And the success of companies like Nicira, Big Switch, and others, I think it's a proof that something is going on in the industry. Where do we end? I don't know.
And those guys are targeting primarily the data center. So as an operator, what holes do you see? Or, I mean, what holes do you see?
I see, indeed, the main focus on the data center. Yes, data center is very relevant for us as well, but there's more than that. And I would encourage also the startups to look at these other environments as well.
The big missing hole is software. In other words, really bringing scalable, fault-tolerant software, exporting these different components of whether it's topology, whether it's monitoring, whether it's management, as building blocks. In other words, if I were thinking in terms of a startup, I'd assume a world where there are OpenFlow switches out there. And someone, whether it's an established company or somebody else, is making them, building them, selling them. Now, what software can I drop in to have these different OpenFlow switches interoperate with one another, providing the necessary management, fault tolerance, et cetera, functionality?
So, I mean, from the wireless perspective, there's a big opportunity in looking at this chaotic wireless infrastructure we have, all these Wi-Fi APs and these cellular networks that have been deployed, and actually abstracting those out and stitching together access that users actually want. So there's a big opportunity there in making Wi-Fi more cellular-like. If you look at Wi-Fi right now, it doesn't really have the quality of service you would want to be able to use it as a wide area connectivity option. But if I can abstract the Wi-Fi complexity out through the software and write software on top that can make Wi-Fi more cellular, like have mobility, have quality of service, and those kinds of things, there's a big opportunity there to reach even the end user.
I'm going to ask one more question, but if y'all have questions, or I can ask a bunch, but start moseying up to the mics now. With the OpenRadio idea, fundamentally, that could change, holy cow, what an ISP is, which I'm sure that you're aware of that. And there's a whole ecosystem in place right now that might use Wi-Fi but doesn't want to rely on Wi-Fi or make it even look like cellular because it takes effort and it costs them money. So what do you see, how do you see that coming from academia into the real world? Or do you? I mean,
sure.
And that's for you and you.
So I'll take that first. So I think what's happening with cellular is these networks are becoming very dense. I think all the providers are realizing that their model of deploying macro base stations to provide coverage is not going to cut it anymore. So they're going to this world where they're trying to deploy picocells and all these kinds of things in every neighborhood or even every home, if you will, right? And at that point, the cellular infrastructure begins to look a lot like the chaotic Wi-Fi infrastructure you have, right? It's a bunch of access points that are deployed out there. And how do you tame this complexity? How do you actually provide the services you want on top of this chaotic infrastructure where backhaul is going to be variable? It's going to be by cable, it's going to be by a microwave, and so on. So it's going to look a lot like that. And if you think about the deployment and management costs of such an infrastructure, it's enormous. I don't think, given how much traffic is rising, the cost per bit is very high if you have to do it in the model you have right now. So having a software-defined networking approach that can actually scale the management and the deployment complexity of this wireless infrastructure, I think it's going to go there. You're seeing it in some countries like India already, where infrastructure sharing is happening.
Yeah, well, actually, we already running some research projects also in the Berlin area, evaluating some similar concepts. But I think we have a couple of non-trivial problems to solve before this will become reality. And then, indeed, it has the potential to change mobile operators and ISPs. But there are still some doubts, and you will have to involve other standardization gremia as well, like 3GPP. And some things just take time.
Operator time or data center time?
Standardization time.
All right, we're gonna start here and just move one to, so go for it.
A question for the gentleman from DT. A thought exercise: if your regulator came along tomorrow and said that you had to implement horizontal separation and unbundled services, what would you turn and demand of Dave in order to make it possible to provide dumb pipes and be profitable? And would SDN factor into that?
Yeah, so indeed you have to build your IP network in the most optimized way, and part of it is what we're doing for TerraStream, that even in the worst possible case, we would still be profitable. And to do that, you really need to change the way you produce services today. And yes, we're doing that, but still we don't see the future as being a dumb pipe provider. Thank you.
A question for Amin. So, building your software defined the WAN, how much did you rely on existing infrastructure? Did you build on top of existing switches and routers, or you had to replace routers or switches in your network? And if you can give us like an idea in terms of percentage.
So again, I think the point for our deployment was we started early. In other words, we first rolled this out in 2010, and our only option for building a software-defined WAN at that point was to have our own gear that had OpenFlow support. But the success of the effort isn't about the hardware. Right? It's about being able to manage the network. It's about being able to have less bandwidth deployed, managed more intelligently, rather than the individual routers that are pushing the bits around.
So a question for Dave Ward. So I'm an operator and I'm looking at running on an OpenFlow network, and I'm looking at Amin's results, and I'm saying, okay, so I can either run a normal Cisco kind of network with a 100 gig line card or one like Cisco with a 40 gig line card. Which do you think is going to be cheaper?
So I'm not sure I understood the question completely. One more time, please.
So if you're looking at Amin's results, he can run his network at close to 100%. So that means he doesn't have to have 70% overcapacity. So that means he could essentially run with a 40 gig line card instead of a 100 gig line card.
So agreed. So what's interesting, and Amin alluded to this or went over this very, very quickly, is the pace and the percentage of percent utilization that carriers currently spin up another fiber, lambda, or link to be able to handle the capacity that's necessary. There's a whole lot of traffic engineering out on the internet today. There's a lot of purposefully placed bandwidth in networks as it exists today. And the function of how hot you run your links is a function of how you've laid out your protection restoration, as you know. And second, the pace at which you could actually spin up those links. If it takes you 6 months to, say, lay fiber or light a lambda, and you know you're going to go from 35% to 70% or 35% to 80% in those 6 months, you do have to start lighting those lambdas early. This isn't a function of really of the router's capacity. It's a function of how the network is operated and the efficient use of bandwidth in the network and the protection restoration scheme. If all the capacity in a network can be used more effectively, without a doubt, there's going to be, again, more efficient use, perhaps more cost-effective use, but there's not much I can do right now about how long it takes to lay fiber in the ground. We can provide SDN interfaces for how to light lambdas and to be able to make those parts of the transport network more flexible and agile, so that's dramatically reduced in that period of time that it takes. We can provide more control, again, over finding the unused capacity in networks, again, through a centralized view. As we discussed, using different technology and different standardized technology than Amin mentioned, and all of those are absolutely possible.
Okay, this is more of a question for, sorry?
No, that's you.
More of a question for Sachin, Katti. And you introduced to us about the method of finding the best access points when there are a lot of access points over there, but you can't use all of them. And 2 days ago, Mr. Brandon Heller showed us an introduction to using 3 access points and 1 WiMAX station at the same time in the university. And several years ago in Spain, they had a plan of sharing home wireless Wi-Fi APs to the general public. And cellular phone APs are mostly set up and operated by individual private operators. So if we are promoting OpenRadio, how do you overcome the private ownership of operations and the password locking of APs and even data security risks when this will be shared?
So great question. So Brandon, and I think KK is the student who gets a lot of credit for actually doing this demo and building that system where we demonstrated that you could use any of the access points that was closest to you. So the question really is, if this infrastructure is going to be deployed by you and me, essentially, right? So at my home, I'm installing an access point, and I want to be able to rent it out to the service provider to be able to provide connectivity to some other user. What's the safety? How do I authenticate that user? So you can imagine starting to layer authentication services on top. So in the demo, for example, we use the Facebook authentication to authenticate what user it was, and that's completely transparent to the infrastructure owner. So I, as a home AP person who deployed the home AP, I don't have to worry about authenticating that particular user. That's completely handled by a third-party service. And one part of the research is how do I make sure that I give isolation guarantees. So isolation guarantees can be of the form, make sure that the guest network does not get more than 10% of the channel time or 10% of the backhaul capacity. So we are extending this OpenFlow interface to be able to give you those kinds of safety guarantees on top of that.
Okay, this is the lightning round, and I'm only going to get to you and you. So
okay.
Everybody else, go.
Hi, I heard a lot of talk about new services, new capabilities in the network. How important is it that SDN, or realistic, that SDN provide the ability to roll out these new capabilities without touching the network infrastructure? Just the software.
So when you mean not touching the network infrastructure, I assume you mean cabling things up.
No, the embedded devices.
Well, it's going to be interacting with the embedded devices at the software layer at the multiple planes that we discussed, without a doubt. I think really what we're seeing, and what's interesting is that we have an OpenFlow and OpenStack suite of conferences going on at the exact same time, because one, it shows the need for open APIs to these things, but also I think it alludes to the fact that the coming together of networking cloud and the ability to have virtualized services is the key. Now, touching that embedded gear is going to be critical to be able to identify the traffic that needs to go to the particular virtualized services or to be redirected into the network. So to be able to cable them up and recable them up, that's exactly what we're trying to fix. We do not want to have to go out and install, every time we want a new service, a new appliance, give it an address, cable it up. We want to be able to unplug that and use the cloud compute resources to virtualize services at the bandwidth capabilities they have.
Last question, right there.
Last question, okay. Sorry, it will be a little bit offensive. So from all the use cases I've currently seen, so most of them are not new, so they could be addressed by existing features. So the problem you're trying to solve is this because the next generation of people is simply too dumb to use our features, or is it about, so the problem is what problem we are trying to solve. And the next thing is about a radio, is like, why do I have to go, if I'm roaming to Starbucks, I have to still click on the next screen to say, okay, I'm agreeing, I'm not doing nasty things. So the same is, it's a business problem. The business problem, because my Google quality for video, for YouTube is bad, is because of tier 1 exchange agreements. It's not a protocol problem, it's always a business problem. So the problem is, are we really solving the right problem? So is OpenFlow addressing the business problem, or is it more the current situation is there because it's because of business reasons?
What's the simplest way? How can you reduce complexity in existing networks? And if OpenFlow helps there, it's the way to go. If not, probably not. Yeah, you can do it other ways as well. But for example, a lot of the business cases on monetizing value-added services were negative because it costed more to implement those than you would get from the users. So you need to have something which makes this easier.
Now, what I'm looking for, wouldn't it be easier for Google to just to distribute their containers and to be closer by the customers to get a better quality?
Okay, yeah, you'll have to talk about it later. Okay, big round of applause for our panelists.